Good morning, everybody. Welcome to the electronics class. Today I'm going to show you how to build a non-inverting amplifier. You can see that I'm already open to PartSim. So while I've already built the project, I'm going to start it as a new project. So we'll click on New Project. PartSim has loaded. It's loaded all its parts. Now what we're going to do is we're going to pick out generic parts. First we'll need an op amp. We'll just go with the basic one. Later we'll use the one that you actually have to specify the power supply for. But for simplicity, we'll just go with the basic one today. We won't bother describing it. It isn't really necessary. We'll need, for our non-inverting amplifier, we'll need a couple of resistors, a couple of ground connections, and a voltage source. So let's go down. Resistors are under passives. So we'll grab two resistors. Here's one. Here's two. I place them in this order so that they agree with what is on the formula that we have. I'll move R1 up a little. We also need ground connectors, so that's under ports. Here's one. And we'll need a second one for the voltage source, so we'll go ahead and grab it at the same time. The final thing we need is the voltage source, so under sources, we'll take an AC voltage source. We'll bring it into position. And what we now will do is connect the circuit. So we'll connect R2 to the output of the op amp. We'll connect R1 and R2 to each other. We'll connect R1 to ground. We'll connect the voltage source to the non-inverting input. We'll connect its other end to the ground. And the final thing we have to do is take our voltage divider and connect it to the inverting input. Our circuit's complete, but we've got to specify some of the components. So the first thing is I don't want the two resistors to be equal to each other. So I'll take R2 and change it, and I'm going to make it a 2000 ohm resistor. So that's done. Then what I'll do is I'll also make a change to the paper. So the output, if you want to make a printout, is letter size. That one we have to apply. So that's done. Then I also have to look at the voltage source. So we'll click on the voltage source. First of all, as it comes, it has a DC component, which we don't want. I want a component of some sort. I'll pick a sinusoid, and there it is. Now, I haven't completed the process yet. If we did run at this point, we wouldn't get any output. So what we have to do is confirm the voltage source, and when we click on confirm, the properties appear, and you can see that the DC got re-enabled, so I'm going to unclick that again, and I'll click confirm, and the DC part will go away. Now I have what I want, so I'm going to run a simulation. And what I'm going to do is I'm going to put a sine wave into this as a transient, and we'll see what the output is. So we'll click Spice Run. We don't want DC bias, so we'll uncheck that. We do want the transient response. And all we have to do now is check run and wait to see what happens. And here it's happened. You can see that the input in green is in phase with the output. In blue, and you can see an amplification of 3 times, which is what we'd expect because the ratio of the two resistors is 2 in our gain equation. The gain is 1 plus the ratio, so that's 1 plus 2, which is 3, which gives us our gain. So that's a nice simple one. I'm going to have you run lots of different inputs and outputs with different circuit properties and different